So welcome to create your own self-service cloud Docker containers as part of a CD pipeline. So if you pull out your bingo cards, the buzzword bingo, I hope someone completes their row. So my name is Nikhil Vaze. I'm a engineer, a software engineer at Electric Cloud. And here's where you can find me on GitHub. I'm at the real Nikhil and on Twitter. So just a few slides about sort of my role at Electric Cloud to kind of to frame the rest of the discussion. Electric Cloud, we sell software that helps other people deliver their software faster. We have two tools I'll be talking about or making references to, Electric Flow, and it's pipeline release automation. And so I could go on, but in a nutshell, from the time a developer checks in to the point where ops deploys that unit of code to production, that's what we're really focused on and zealous about. In particular, I spend a lot of my times on integrations. As all of you know, that there are just a ton of tools from different types of source controls, different types of application servers, and of course, clouds. So I am the team lead for our integrations team. And as part of that, EC2, the cloud, Docker, all these pieces fit firmly in that. So that's what I'm going to talk about today. And just a little bit of a shout out or my experience with Docker. I'm at work. I frequently wear a lot of Docker t-shirts, and I have to tell people, I'm an Electric Cloud employee, not a Docker employee. I'm a co-organizer for Docker Santa Clara. It's a meetup, and I participated in the hackathon, the first and second hackathon. We did pretty well the first time, and did a talk last year at DOES, a quick lightning demo. So I'm asking this question because last year I asked a similar question, and I'm curious to see kind of the responses. So this is my only kind of audience participation, so if you'd humor me. If you could put your hands up if you've heard of Docker, okay? If you've typed Docker run, keep them up. Okay, so if we pause right here, last year I asked this question, and I had a very technical talk. Everyone but one person had put their hand, only one person had their hand up, and then he looked around and he was like, oh, then he put it down. So, okay, so do you use Docker in dev test? Keep them up, great. Do you use in production? Okay, that's great. And then the last one is, have you exported a Docker container and run it with systemd nspawn? Woo, nice. Okay, that's black belt. I don't have anything left. Okay, so that helps me calibrate a little bit of the future slides. So what I'm here to talk to you today about is an overall problem of just self-service clouds and how we've seen a problem or how we've encountered it as Electric Cloud. What we hear in industry, how we're thinking about this problem as it relates to our product and as it relates to Docker. So it's going to be about maybe 20 more slides than a demo, but everything I'm talking about should be abstract or should be high level enough that you can choose your tools of choice. When I say one thing, you can sort of think of another. But I hope you think of the tools that I'm talking about. So if anyone has been to DockerCon or has seen the presentations from 2015, this was from GE, and it was a pretty good talk about how they initially had a problem where it would take a very long time for development teams within their organization to acquire or get the machines needed to do their jobs, really. That's what it boils down to. And as the talk progressed, they showed different versions of this slide where it was going smaller and smaller from, I think the topic was like from months to minutes. So this is very common. We hear this all the time. You have an enterprise has a huge developer base. They have an IT team that is in charge of provisioning or giving machines to these developer or testing groups. And it is just not speedy. It takes a very long time. Once you get it, you hang on to it for your dear life. And these are the themes that I'll be going over. I'll give kind of some more concrete information. So this is the old way, right? You file a ticket, someone manually runs through a run deck or a wiki page and spins things up, hands it back to you. It's not, step 55A was done incorrectly, so you have to take some time to remediate that. On the other hand, with part of this aspect of getting machines, cloud has really helped kind of solve that or help towards the solution. But in this presentation from Intel at OpenStack Silicon Valley, the cloud, I hope you guys can read it. It says less than 10% of enterprises have adopted cloud. And when they do, it's actually predominantly public cloud. And Intel is a sponsor of, I think, or is a backer of Mirantis. So there's a little bit of that angle. They want to pitch OpenStack, et cetera. But predominantly what I'm trying to say here is the cloud has been around for a while, but enterprises have not quite adopted, if you were to believe Intel here. And that sort of matches what we see as well with prospects, users, and customers. So in 2014, a Fortune 500 company came to us, and it's basically that the GE, that graphic that I showed before, that one group provides infrastructure, another group provisions, another group does the data load, and by the time the initial users got whatever they requested, it would be a month later. It would cost a lot of money. Once they had it, they'd hang on to it for their dear life because they didn't want to go through that process again. So a customer kind of came to us and said, hey, these are our problems. And so we're Electric Cloud, we care about software delivery, right? So in 2014, we helped them and come up with this sort of solution. And so we were called, our Electric Flow product was called the Commander Server, and it was a lot of do-it-yourself kind of PS work that went on to get this solution. But we were like a workflow engine that called out to all these different pieces. But we asked ourselves, hey, we're hearing this. Hey, how common is this? Could we make this into a feature? And around, Docker really started getting steam probably in 2014, even 2015, right? But we sort of saw that, hey, how is Docker going to affect all of these problems? So that brings us to kind of dynamic environments and self-service clouds. And what I would say, kind of independent of the slides here, is that the cloud solves one problem, which is elasticity and getting you the machines. The Docker container, or just a container, that solves the problem of having the user or developer who is most familiar with the app in charge of writing the app, packaging it, and handing it off to operations. So I would say you kind of need both. You don't need both, but these two concepts really work well together, where you give a self-service cloud and you say, hey, what should I run on that cloud in this container? And that's what I'll be showing in a few minutes. So we called this dynamic environments, and from an overall perspective, it's a user or a group specifies a blueprint, and you make it available to the rest of your users. And it's, it plays well with other configuration management tools, and you can also run Docker inside of these VMs as they spin up. So here's my intro to Docker. I guess I'll go a little bit faster. I was imagining kind of last year's results. So just to keep everyone on the same page, an introduction to Docker. Why are people excited about containers? And here are my kind of opinions. For the most part, how I've seen organizations, or when I have a phone conversation or WebEx GoToMeeting, people always start towards the developer. How can we a dev found out about this, is really excited. How how do they start thinking about it, right? Okay, let me do my builds. We get great file system isolation. It's reproducible. In the old days, at least within Electric Cloud, we used to put tools on a network share. Our build lanes used to reference that network share, and you would do your build. And it would take a long time to get your new tools on that network share, right? Because initially it was open and readable, readable and writable. Then someone goes ahead and writes to that. Builds break. Oh, why did this build break? And then for a week you go around, nothing's changed. The network, the file share changed, right? So people are moving toward, or as I see it and hear about it, people are moving towards containers that hold Maven or the Go cross-compile tool chain. And the developer who does the builds themselves encapsulates or authors this logic into the container. And this way you don't exactly solve the file system problem. You push it away a little bit to, okay, now where is this container? It's in a registry. Okay, how should it be tagged? Who has access to it? So it doesn't exactly solve the issue of, the image can change and your builds can break. So you still have to pay attention to that. But it's I think it's a little bit better than a shared file system. So anyway, that was kind of a little bit of a tangent. The last thing that really gets me excited is finally we've got Microsoft on board. I don't know if anyone from Microsoft is here, but before Docker, a lot of open source tools like Vagrant and Chef, I have a Windows laptop here. You would run these tools and it would be like, haha, very funny, right? Like go to a Mac or go to a Linux, right? We don't really care about Windows right now. And the reason why the Docker CLI works on Windows is because 2 engineers or more from Microsoft are contributing to the open source project. And that fills me with joy, to know that, hey, finally, I'm not abandoned as a Windows user. So I credit to Microsoft and Docker for that. All right, so real quick, Docker, it's open source, used to wrap LXC. Really, it's really fast, right? So at the first hackathon, one of my coworkers, he kind of got up there and was, normally used to VMs and started a container and was just like, it is really fast, right? Like milliseconds. And the rest of the audience was kind of like the Docker, the fanboys and the early adopters. So they were like, yeah, we know. But when you first show this to someone, it's still, it really boggles people's mind. Very high level, the difference between containers and VMs. Containers have a hypervisor, there is no kernel module sharing between the host and the guest. So you can have different versions of the kernel on Linux. And so, okay, those are VMs, right? Containers, you do share parts of the kernel between your host and guest. On your host, you can do a PS, EFL, grep, and from your host, you can see the processes in the container. So these are just some small, differences. And at the lowest level, Docker is just wrapping core Linux primitives. And this slide is a bit out of date. So it used to be libcontainer, now it's called runc. But they did a Go implementation. Docker wrote a Go implementation that in turn calls the core Linux primitives. So that's, hey, that's Docker from a high level. And so Microsoft wrote this slide, right? So there's Windows support that's getting there. There's Linux. One thing is, if you are on Windows, I don't believe you will ever be able to create a Linux VM and kind of or Linux container and vice versa. It's like the Windows Docker daemon will create Windows containers and Linux to Linux, unless that is, things change so fast that I hope what I'm saying is correct, As far as I know, that's what I'm saying is correct. And so if you had to explain this, this diagram is like, if you had to explain this to someone else, or, as, this is from my experiences with the Docker meetup, it's what is running where. So a lot of people don't, it takes, once they figure out what is running where, they can keep on following you. So what I'm just trying to say here is you have a Windows laptop, which is the purple, rectangle. You have tools that are installed to the left, your Vagrant client, your Docker client, and with those are installed on your host. You have VirtualBox typically, and within VirtualBox is a VM. That VM is Linux. It runs the Docker daemon. So when you are on your host and you say Docker run, it goes from your host through the VM to the Docker daemon that's running on the Linux host. And maybe perhaps now it's, I don't know, perhaps I'm speaking from experience 6 months ago, and now this is crystal clear for everyone. But when I still run it, or I find this helpful when explaining it to people. So let me go over kind of the demo that I'm going to show, first in slides, and then I'll go through it via the web browser. So I want to give a shout out to Jason Wilder. So I've never met this person, but I also talked about his blog post last year. And the link is over there, and this is the architecture that he's going over. And it's, briefly, there's a client, and that runs HA proxy, right? And your users talk to that client. And etcd is the service discovery, so it holds the coordination, or it's the service registry. What is the state of the cluster? What are the IP addresses? And now you have the two, in his case, backends that are just kind of who am I containers that are serving up web content. And the idea is that the who am I's are the application. The Docker registers are, let's see, the sidekick processes that connect or tell etcd, hey, this is who I am. And the Docker discover is the sidekick process that says, okay, given this information in etcd, what are my HA proxy rules that I need to write out, or what do I need to serve to HA proxy? So this was really, this kind of blew my mind when I read it like over a year ago, where you can have a lot of, it's very easy to scale this, right? Because they're sidekicks. You can keep going with new backends, et cetera. But the one thing that's missing, in my opinion, from here is a backend. It's a lot of times we talk about stateless apps, but the reality is most of us have data. And we have databases. So I wanted to add a stateful database to this diagram. And okay, okay. So here is the app that I'll be talking about. It's very similar. The load balancer is HA proxy. There's still service discovery. But there's an application, and it's going to be a flight reservation system that is talking to a NoSQL database called Couchbase. And the change that I'm going to make is this all is living in one availability zone on Amazon. I'm going to add a second availability zone and create create a new web, create a new NoSQL database. So if you grant me a little bit, I didn't quite have enough time for the load balancer and service discovery. So I do have single points of failure in this demo, but if you, I tried to remove those in the application and the database. So yeah, so here's a before and after. This is what you're gonna see with HA proxy. So it's pretty small, but that green row is gonna go from 1 row to 2. We're going to see Couchbase go from 1 entry, 1 node to 2 nodes. And the front end is going to look like this over here to the right. And it was created by Couchbase employees, uses a lot of JavaScript. But yeah, it's just a flight search and reservation tool. And etcd that's the service discovery service registry that we're using. It's open source. It's used by, it's created by CoreOS. Before I demo, just one last thing or one more thing. Everything I'm about to show you can be done via our community edition. So Yes, so I am an electric flow engineer. I love it, and concepts are easy for me to model within Flow, so I do. You can try it right here, or you can, you'll have to do a little mental map when you hear what I'm saying to translate it to your tool of choice. All right, so let's go to the demo. All right, so this process, okay, so let me go to our application. I'm going to kick off the run because it takes 6 minutes. So give me a second to just kick it off and I'll kind of talk about what I am doing. Actually, I take that back. Let me show you the before. So this is HA proxy, right? We have one node. This is our app over here. So, you know, SFO, let's go to LAX. And, you know, so you can kind of see that the app is working. And the idea is that what I just did right now should work after we've added that redundancy of a second application and a second database. And, oh, sorry, one last one, which is, here's Couchbase. So there's only one active server right now. So with that being said, let me kick this off. Environment template. Yes, east. Okay. All right, so this is going to take about, let's see, about 5 minutes. So while this is running, I'll kind of explain how we think of things over here. Okay, great. So we have an application, you know, I've called it the does 15 dynamic environment, and we have various processes within here. Specifically, what I am adding, or what I am running, is the add node. And you guys, okay. You can kind of see you can do pulls, and so I'm pulling the Docker, the Docker images. I'm running the database. I'm running web. I'm doing some coordination, and then I'm running my Sidekick. So that is sort of the orchestration. Like, hey, these are containers. What's the order that they should be spun up in? And specifically, this add node piece. Let's see. This is kind of where we're doing our rebalancing. So once we've seeded data in Couchbase, we have to add this new node to the cluster, redistribute all the data, and then activate or like send traffic. So I'll go back. Sorry, give me a second. What I'll do now is talk a little bit about the dynamic environment aspect. So I ran the process that I just went over on an environment. What is an environment and how would you create one, or how do we think of one? Let's see, right over here in environments, we have we have something called a resource template. And inside the resource template, you can specify what is the type of VM you want for this resource. So what we thought here was, listen, your users are one group of people. The administrators of EC2, in this case, can provide or help define with the users what instance or what configurations should show up for this type of app. So over here you can see we pull in some data from EC2. Yeah, and the idea is the administrator writes this, and now users later on, they can just click play and run. So this is how we kind of take the dynamic environments and how EC2 and containers relate to each other. This is kind of the central point. And so I could go next and create it, but at this point I'll go back to the previously run process. Oh, okay, so we still have 2 more minutes. All right, I guess I'll talk a little bit about deploy. I guess I'm speaking a little bit faster. Let's see. All right, this is just, I guess, our view of our of the job and the steps that we took in order to execute. I guess, you know, what would be more interesting over here is the actual definition. All right, so what's over here, it's similar to the process I showed before, where you can model, you know, what is running, what can you do in parallel, and what do you have to serialize on. You can kind of notice that we have, our environments have tiers. So there's web, database. So a single command, or when we specify something in this box, it runs against all machines that have kind of been tagged or are known as like as a database or as web. Let's see. All right, so let's go back to the running process. This should complete in about a minute. Let's see. Okay, so over here, my web node has been created. The Couchbase instance is created. So I guess I can go, we can go and take a look at some of the new resources that are here. All right, so this is our database. So you can kind of see that it's, we now have 2 active servers. So, you know, this was my screen before, where there was 1. Now we have 2. And I think we should be seeing a rebalancing happening pretty soon. You see that we have, okay, we have 1 data bucket. Let's take a look at the log. Okay. So, you know, at this point, the Couch, I believe the Couchbase server, the 2 backend servers, they were populated with information that lived, most of the data lived in 1 server, and now it's spread out between the 2. Let's take a look at HA proxy. And now we see kind of the second, you know, the second instance that's, that has been created over here. And if we, I guess if we go to just port 3000 over here, you can see that, hey, the load balancer has directed us. And if we were to, again, you know, take San Francisco, let's go to Paris, maybe, you know, let's go next week. And now, you know, the information will pop up here shortly. Yeah. So, you know, this is how we took an app from that was living in 1 availability zone, and really, yeah, we added another zone and added the application database. It's per AWS best practices to have, you know, have redundancy. So I will go back to my presentation over here. So, all right. So with that demo, you know, or kind of concluding, yeah, kind of some concluding thoughts. The cloud, you know, your organization with the enterprise, your enterprise organization, it may or may not be using cloud, but the same concepts still apply, whether you know you're using VMware or you even have kind of bare metal servers. You know, you can still provide this self-service aspect. The elasticity will, you know, won't quite be there. But clouds, if you do have a cloud, it will initially, you know, it will help. But you need something on top of it to really empower your users. And what I would say is, you know, the self-service aspect, or creating a portal to help your users install their software, be shown what their usage is or what the cost would be. That's certainly something that can help you go from code all the way to production faster. Docker, of course, makes things easier. And the last one is this is only possible if you have automation. And kind of a step zero with automation is you have an understanding of your application. You have scripts, and you have scripts that can make your application do something, right? But if there are mysteries within your app, if you don't understand it, there are other problems you need to solve before you can get to something what I've shown. And not at my current job, at previous jobs, this was definitely the case. Like automation, yes, it would have helped us, but our biggest bottleneck or our problem was lack of familiarity with the app. So really make sure that before you get to this point, there's just understand your app, have tests, get your automation in place. Then you can kind of eventually you can get to this, and it is attainable, but it's a step-by-step process. Oh right, yeah. So one last thing, before I forget. So I mentioned that I'm the team lead for our integrations at Electric Cloud, and we are going open source. So we have open sourced 12 or so integrations, including cloud, right? EC2, OpenStack is there, Docker is there. So it's something we're going to continue to work on, and we hope to get a community. So if you've used Electric Flow before and you'd like to try it out, kick the tires, here is the URL to see our landing page. And I look forward to talking to everyone who's interested about this. So with that, I know I'm quite early, but I'd like to open it up for questions. Yeah, so the question was, hey, I see these plugins on GitHub. If I fork it and make a change, can I then submit that change back to you, and then will you go ahead and test it and then merge it into the mainline? Yes, that's the overall goal. So right now we've made the sources available. We're using Gradle as the build process, and we're using GitHub, just standard pull requests. So we've done we hope we've made it very easy to compile. So at this point, there's the fork, and as time goes, you can fork and build, test it within your own environment. As time goes on, we want really robust tests that are already within the repo. So we have, so I guess, Lucas, I can give you the specifics after, but short answer is yeah, that's what we'd like to get to. Do you want to?
Oh yeah. Is this mic on? I'm not sure. Anyway, you can repeat it.
Okay. Yeah. Sure.
Are you deploying Docker containers that have been pre-built, or are you spinning up a Docker container and then pushing stuff to it as part of what you do?
Yeah. So the question is, are these containers? Are the container? Let's see. I think actually, what would be a better slide is let's just talk. All these pieces over here, how did you create them, and are you injecting content, or has the content already been baked in? So for the purpose of this demo, we baked it in. The Docker container is merely another component or artifact. Just as you have WAR files or zip files that make up your deploy, a Docker container is now an artifact that is part of your deploy, and you can bake everything inside and run it. So if you want to rev your application, you would rebuild the container, publish it to an artifact repository, and then consume it. And that's the model. So we've done both ways. But this way seems to be in industry. This way seems to be the more prevalent or more popular one. Yeah, so the question is, are you able to version the environments and are you able to put them into source control? So yes, I don't have that demo ready, but I'll just, let's see if I can navigate, okay, I'll say it verbally and then I'll see if I can navigate. Yeah, we have concepts of snapshots, so you can take an environment, snapshot it, all the artifacts and what versions were deployed to that environment get captured. Specifically with source control, a lot of times when users see this UI or prospects or they say, hey, it works well for my first Hello World app, but when I need to scale this to 100, 1,000, what do I need to do, right? So you can continue to use the UI, that's fine if that's the way you want to go, or you could write a script or a DSL, domain-specific language, and what when we were doing kind of requirements gathering for creating the DSL, there was the biggest request was, I have a deployment or a build process that looks a certain way. A year later, I may need to support that again. So I would like a snapshot of what exactly went on so I can reproduce this. So you see this kind of, in this case, it was the airline industry. But what I would say is you can take snapshots for your environments, have them there. If you want to go one level further, everything I've shown in the UI is capable to be defined within the DSL. And you check that in, you run it. In fact, like this demo, parts of it are backed by the DSL. And when I do a demo in the future, I'm just going to reuse the DSL, because UI clicks you lose to a certain extent. So I hope, does that answer? Okay. All right. Well, yeah. Thank you for attending the talk. I hope Go Docker, self-service clouds, and electric flow. And yeah, thank you for your time.